Hey guys, welcome to the level 1 MCAT paper from 2022. This is day 2's paper. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about with the question. So without further ado, let's get started. Alright, so question 1a. What we've got here is we've actually got a rectangle and square. They both have the same perimeter. Now, if you are talking about perimeter, remember that perimeter is literally the border. So you've got to actually add those 4 yellow lines there. Now, you've got a square on the right hand side. So that means you've got 7 and 7. 4 times 7. Sorry, I should have used this. So you got 4 times 7 equals 228. All right. Now, that's the square part of it done. As for the rectangle, remember that you're still doing the perimeter. So you've got the green, or the top green, the right side, and the bottom. They've all got to add up to 28. Now, when you are doing perimeter for a rectangle, remember that you've got to cover both sides. So you've actually got 2 lots of 3x minus 5 plus 2 lots of 5x plus 3, and all of that is equal to 28. All right, so hopefully you guys can get that. Now the next part is we need to expand the brackets. So we're going to multiply 2 times 3x, which is 6x. 2 times minus 5 is minus 10, plus we've got 2 times 5x, 2 times 3, which means we've got 10x plus 6, and all of that is equal to 28. Now, at this point, what we're going to do is we're going to collect our like terms. So we've got 6x and 10x, which equals to 16x. We have minus 10 and positive 6, which equals to negative 4. And this is all equal to 28. So we have 16x equals 28. The minus 4, when it comes to the right hand side, becomes plus 4. And we've got 16x is equal to 32. And then we can say that x is equal to 32 divided by 16, which means x is equal to 2. Now, this question is worth and achieved. Now, is this going to work for me? Yes, it is. That's great. So as you guys can see, this question is actually worth and achieved, but you've got to form and solve the linear equation. So if you just write the answer of x equals to 2, you probably won't get a grade for it. So you'll need to write up some sort of equation to actually get that achieved grade. Okay, so with question 1b here, now when they give you this kind of question, a most common mistake that I've seen people do is the first thing they do is they do this, cancel out the x squareds and then start doing something crazy. Now this is not the case. All right, if you see a quadratic that's getting divided by a quadratic, you have to know this. All right, this is like one of the easiest merit questions you're going to get in the MCAT. They'll always, I think anytime you see a question like this, just remember the numerator is going to be broken up into 2 brackets. The denominator is going to be broken up into 2 brackets. And one of those brackets will get cancelled out. Like literally, this is like one of these bread and butter questions that you get in the MCAT. And it's like every year it pops up and then it disappears and it keeps coming back. So anyway, with that in mind, our first thing we're going to do is we're going to look at the 4x squared minus 25. Now looking at that, we can straight away see that those are square numbers. So we can straight away do this. 2x minus 5, 2x plus 5. And I think it's like sum and differences. Jeez, I'm starting to lose my sum of differences. I don't know, I can't remember. Anyway, it's basically that thing, right? Like you know that you can actually factorize, but the symbols get swapped over. All right, now when we have the bottom one, 8x squared minus 2x plus 5, that's the one that I always say to you guys. You guys kind of need to do this on your own. All right, like people have different styles of doing this. Some people use quadratic formulas. Some people kind of just do it guessing and checking. Whichever method works for you, stick with it. All right, so what I'm going to do, 8x squared minus 22x plus 5. The first step is I multiply 8 and 5 to get 40. And I'm looking for two numbers, basically two numbers that multiply to positive 40 and add up to negative 22. Now I know in this case it's negative 2 and negative 20, because negative 2 times negative 20 is 40, negative 2 plus negative 20 is negative 22. So then I am going to replace the negative 22x with negative 2x negative 20x plus 5. At this point I'm going to factorize by parts, so I'm going to separate it into two parts. Now on the left hand side I could see that 2x is a common factor, which means I'm going to get 4x minus 1. Then on this side I can see that 5 is a common factor, so I've got positive 5. But really I don't want to take positive 5, right? I want to take negative 5 because I want to have that 4x minus 5 happening. Now I'm going to show you this extra step here, because if I take 5 out, I'm going to get negative 4x plus 1. But the problem is I need these two brackets to be the same. So a good tip for you is that if you do end up making a mistake and you're like, well, those two brackets are not the same, you can factorize it further, because in this case I could actually write this as 2x 4x minus 1, and I could actually take negative 1 as a common factor from here, which means this will become negative 5, this will become positive 4x minus 1. And at this point I've got 4x minus 1 as a common factor, 2x minus 5 as the other common factor. So the 2x is from there and negative 5 is from there. Now this is pretty much the hardest part for you guys in this question, because straight away what we can do is we can replace that quadratic with this. We actually cross out our common terms or factors in this case, and what we left over with is 2x plus 5 divided by 4x minus 1. Now grades wise, is this an achieved question or a merit question? Definitely a merit question. If you guys have a look, this is a merit question. All right, which means for the achieved you just need to get either the top line correct or the bottom line correct. And for a merit, you just have to cross out that common factor. And I think once you do that, you are looking at a merit. So this is what a merit is. Achieved is actually getting either this or the denominator correct, and you're pretty much good to go for this question. Now, I always say this, guys, like, you know, when you see this question coming up, you should just be like, oh, this is one of the easiest merits, because you know you're going to have two brackets at the top and two brackets at the bottom, and you know that one of those brackets is going to cancel out. And if you can't see that, then you just got to play around with that question until you can actually figure that out, because it actually is one of the easier merit questions to get. Okay, so getting to question 1C. What we've got to do here is that we've actually got, you know, once again, we've got a quadratic, double quadratic. And I know a lot of times most people tend to do this where they're trying to cross multiply and kind of make life extremely difficult for yourselves. Please don't do that. What we are going to do is we're going to factorize the numerator first. All right, now x squared minus x minus 6, we can say that this is x minus 3, x plus 2. And then in the numerator, we've got x plus 7 and x plus 2. Now this is all equal to 3x over 2. What I am going to do is I'm also just having a look at the answer schedule just to see what you could get achieved for. Now if you get this part correct, both the top and the bottom, and you got to simplify. Sorry, that means let's actually not put achieved here. We're going to cross out our x plus 2's, and what we left with x minus 3, x plus 7 equals 3x over 2. Now if you were to get to this stage of for the left hand side, you are already looking at an achieved for this question. All right, that's how easy it is to get a cheat for this question. Right, now we're going to show you guys the next step as to what you need to do to get a merit. I don't know why we said we, because it is just me doing this, but so the next step, what we're going to do is we are going to cross multiply, and when we cross multiply this, we're going to get 2x minus 3 equals 3x times x plus 7. All right, so remember, when you have a fraction that is equal to another fraction, we cross multiply. At this point, we need to expand the brackets, so we're going to get 2x minus 6 equals second bracket, we've got 3x times x, 3x times 7, which is 3x squared plus 21x. Rearrange this so that the left hand side is 0. Doesn't matter, you could do right hand side is equal to 0 as well, but my positive 2x, when I switch it over, becomes minus 2x, and negative 6, switch it over, becomes positive 6. And of course, simplifying this, I'm going to get 3x squared plus 19x plus 6. Getting to this stage is going to get you a merit. All right, just getting to the quadratic equation and equal it to 0. That's pretty sweet. Now, all we've got to do is we've just got to factorize the quadratic. So 3x squared plus 19x plus 6 equals to 0. 3 times 6, I've got 18. I've got 19 in the middle. I am looking for two numbers that multiply to 18 and add to positive 19. So it's quite a nice one. It's just 18, 1, 18, 1. So I've got here 3x squared plus 18x plus 1x plus 6 equals to 0. So split them up into 2. Common factor. I guess in the left hand side I've got 3x, x plus 6. Now on the right hand side, I've actually just got x plus 6 by itself. So I'm going to take out just 1. X plus 6 equals to 0. And at this point, because I've got x plus 6 as a common factor, I'm going to write down x plus 6 bracket. And in the other bracket, I'm going to get 3x plus 1 equals to 0. And remember that 3x is from here, and the positive 1 is from there. Now I need to solve this, guys. So I need to actually put this x plus 6 is equal to 0, or 3x plus 1 equals to 0. Now when x plus 6 equals to 0, that's straightforward. We can say x equals to minus 6. As for this, we're going to get 3x equals minus 1, and then x is equal to minus 1 divided by 3. Now you're going to need both solutions. All right, if you don't get both answers, you don't actually get the full excellence grade. But when you do get both of these answers, it's pretty much an excellence grade there. So I guess the key thing is factorize, get rid of the common factor, cross multiply, rearrange to a quadratic, solve for a quadratic, and you are pretty much good to go there. Okay, so we've got somebody playing netball Monday, Tuesday, Wednesday. On Tuesday, she scored 3 times as many goals she did on Monday. Okay, so here's what I'm going to do. The first step I'm going to do is, do I actually know how many goals this person scored on Monday? I don't. All right, I don't know what that number is, and therefore I'm going to put that as x. The second line says on Tuesday she scored 3 times as many goals as she did on Monday. Now think about it like this, right? If I scored 2 goals on Monday, then on the Tuesday I've scored 6 because it's 3 times 2. And that's the exact same thing I'm going to do here. So if I look at it as x, then on Tuesday it's going to be 3x. Finally, if I go to Wednesday, what's happening Wednesday? Wednesday, it says she scored 16 more goals than she did on Monday. Now remember that example I talked about. If I scored 2 goals on Monday, so this is just an example on the side there. If I scored 2, then on Tuesday I scored 6. On Wednesday, 6 is 3 times 2. On Wednesday I would have scored 16 plus 2, which is 18. Or I would just go 16 plus 2. But algebraically, instead of 2, I would just write this as 16 plus x. That's pretty much it. Those 3 lines there, I've converted them into equations. Now, if at any point you have a problem with word questions, just take a random number and just try and substitute that number just to see what kind of numbers you would get, like I did with this example on the side here. But now that I've got my equations, it said she scored a total of 111 goals over the 3 days. So all of these 3 things added up equals 111. So I can write this as an equation now. I could just go x plus 3x plus 16 plus x equals 111. Count the number of x's, 1, 3, and 1 more there, which is equal to 5x plus 16 equals 111. 5x is equal to 111, take away 16. I'm going to get 5x is equal to 95. X is equal to 95 divided by 5. And I'm going to get x is equal to 19. Now, really important that you actually read the last part of the question, because I didn't read the last part of the question. The last part of the question actually says, how many goals did she score on Wednesday? So on Wednesday, because remember, x is what she scored on Monday. So on Wednesday, she would do 19 plus 16, which equals to 35 goals. So grades wise, you've got to form a correct equation in order to solve the problem. That's part of it. You could get an achieved just at that top line there. For merit, it's fairly obvious. You've got to get that 35 goals to actually get a merit. Okay, that's pretty much it for this question. So with question 1E, what we've got here is we've got a closed cylinder. They've given us a formula here, which is that area equals 2 pi r and r plus h. All right, that's the area. Now they're actually asking us to find the radius. So here's the thing. They're asking us what is the radius when the surface with surface area of 27 pi. So that's that surface area there. And a height of 7.5 centimeters. So that is there. All right. So what we've got here is area is 27 pi equals 2 pi. Now the radius, we don't know what it is, so we're just going to leave it as an r. And we've got an r plus this height is actually 7.5. Oh, resume. Okay, so I guess the next part of this question is, we've got pi on both sides. We just get rid of the pi. Get rid of the pi. How do we do this? Well, we've got 27 pi equals, move just that pi to the denominator here, which means you're going to be dividing by pi, and you've still got everything left there, which is 2r, r plus 7.5. Now, at this point, your 2 pi's are going to cancel out each other, and you're going to get 27 equals to this little thing. But what I'm going to do is I'm going to expand the brackets. So 2r times r, which is 2r squared. 2r times 7.5 is 15r. And what I end up with is a lovely quadratic equation, which is 2r squared plus 15r minus 27. Now at this point, it's a quadratic, guys, and we've kind of talked about this already in this last, I think 3 or 4 questions that we did. We are going to actually factorize this quadratic and solve for r. So the way I'm going to do this, as usual, I'm going to take the 2, multiply with the 27, which means I'm looking for something that multiplies to minus 54 and also adds up to plus 15. -9 No, 18 and 3, of course, 18 and 3, negative 18 and 3. There we go. Positive 18, negative 3. Would that work, Talia? I think that should work. So you kind of like drift off into a thing. All right, let's try this again. Okay, so we've got 2r squared. We'll do plus 18 r. Now I'm going to put that in black actually. Plus 18r minus 3r, and then we've got minus 27 equals to 0. Thank you for picking that mistake up. We've got 2r as a brackets, which means we're going to get r plus 9. Minus 3 as a common factor, we're going to get r plus 9 equals to 0. So we've got r plus 9 and 2r minus 3 equals to 0. And then we've got r plus 9 equals to 0, or 2r minus 3 equals to 0. So r is equal to minus 9, 2r equals positive 3, and then r is equal to 3 divided by 2. Now the thing is, we've got to go with the positive answer. We can't actually have r as a negative value, so we're just going to write a little statement that r can't be negative. Therefore r is equal to 3 over 2 or 1.5. Okay, so grades wise for this question, number 1, number 2 is all worth achieved. Let me just see. Simplify, factorize quadratic equal to 0, that gets you a merit. So getting to this line here gets you a merit. Simplifying equation to a quadratic equation, so somewhere here, simplifying equation to a quadratic equation. Oh, factorized equation. Sorry. This is actually worth achieved. Simplifying to a factorized quadratic equation equal to 0. So this is going to be a merit here. And then, of course, excellence is the final part. I know I made a mistake, and I kind of was like, massive shout out to Talia for picking it up. But yeah, this is going to be on record now. Great. But yeah, that's pretty much it for question 1E. So with question 2A1, part 1, what they're actually asking you to do is find the perimeter of the shape. So if you're going to find the perimeter of the shape, all you're really doing is just adding these 3 sides together. And I guess the key part here is fully simplify the expression. So I've got 4x squared plus 7x plus y plus x minus 3 plus 3x plus 2. Now at this point I'm going to collect all my well, I've only got 1x, like the x squareds. I've only got 4x squared. The next thing is I've got 7x, x, and 3x, so it's 7 plus 1 plus 3, which is 14. No, not 14, 11x. I've got 1y, so plus y, and then I've got my minus 3 plus 2, which equals 2 minus 1. Now for this particular question, you have to simplify the full expression for an achieved grade. If you don't, then unfortunately it looks like yeah, no alternatives accepted, so you actually have to write the fully simplified version of this answer. Alright folks, so for question 2A part 2, what we've got is we've got a follow-up question from the previous question. So I've kind of copied the triangle down just because I don't want to go back and forth referring to this triangle here. So I've copied it down here, and what they say is if the area of this triangle shown above is 7 centimeters squared. So we've got the area of the triangle, the actual area of triangle is equal to 7 centimeters squared. Then they're saying find the value of x. Now we also have the base. The base of this triangle is x minus 3, and the height of this triangle is 3x plus 2. Alright, that's all you need. because then what we're going to do is we're going to substitute area of a triangle, which is 7, and then we've got half, and multiplied by base, which happens to be x minus 3, multiplied by height, which happens to be 3x plus 2. That's pretty much your starting point there. Now once you do that, what you have to do is you've got to rearrange everything, get it to a quadratic equal to 0, and solve. Alright, so the first thing I'm going to do is I'm going to get rid of that 2 from the denominator and bring it across to the other side, which will make it 2 multiplied by 7. So I'm going to get 2 multiplied by 7, which equals x minus 3 and 3x plus 2. Now 2 times 7 is 14, and I've got a quadratic that I need to actually expand. So I've got x times 3x, x times 2, negative 3 times 3x, and negative 3 times 2. And when I do this, I'm going to get 3x squared plus 2x minus 9x minus 6. I hope I've done that right, because I do have a habit of making really silly mistakes. So Raymond, you asked before, if this is something that you'd actually, I talked about quadratic being simplified, but what we have here is 14 equals 3x squared minus 7x minus 6, and we're gonna bring the 14 across, which means we're gonna get 3x squared minus 7x minus 6, and of course we've got minus 14 there. So finally we're going to get something where we're going to have a quadratic that is 3x squared minus 7x minus 20. Now we need to factorize this, and as we've done earlier in this video and these types of questions, we're going to, if you know how to factorize this in your own way and you're completely happy with the answer, then by all means you can go for it. And as always, I'm going to do the method that I kind of mess around with, which is I take the 3 and multiply it with negative 20, and I get negative 60, and I've got negative 7 here. So basically I'm looking for two numbers that multiply to negative 60 and add up to negative 7. Yeah, so 12 and 5 is what I'm looking for here. Negative 12, positive 5, negative 12 and positive 5, negative 60, negative 7. Yeah, that looks right. So then I'm going to have 3x squared minus 12x plus 5x minus 20. Now remember, all of this is equal to 0. And then I've got to split the two terms. I'm going to factorize the left-hand part of it, where I've got 3x and x minus 4. And the right-hand side of that pink line, I've got 5 as a common factor. And once again, I get x minus 4. Remember that 5 is actually a positive 5, so we're going to put that little plus there. And now I've got x minus 4 as a common factor and 3x plus 5 as another common factor. And remember, 3x is from here and the 5 is actually from there. Now we're not done with this question yet, because we've actually got to figure out what the two x values are. So we've got x minus 4 is equal to 0, which means x is equal to positive 4. And then we've got 3x plus 5 equals to 0. So we can say that 3x is equal to negative 5. And then finally we can say that x is equal to negative 5 over 3. Now again, if you look at this particular question here, you can see that x equals negative 5 over 3 doesn't work, because if I put x equals to negative 5 over 3 as this base, you're actually going to end up with a negative value for a base. So we're going to kind of say that x can't be negative. Therefore, x is equal to positive 4. Now, I know this seems like a lot of work for a merit, but it is actually, it's just, at the end of the day, if you think about it, it's just a quadratic formula that you're rearranging. So that final answer of getting both of those answers, you are looking at a merit. For achieved, you are looking at forming the quadratic equation. So that's basically up to you've got to get to this line here to get to an achieved. So again, if you think about it, if you substitute that x minus 3 and 3x plus 2 in the brackets, expand it, rearrange, and you pretty much can get an achieved. Okay, so with question B, what the question is actually asking here is like, it's saying find an equation for P in terms of Q. So basically, your final answer should look something like this, where P is by itself and Q is actually on the right hand side of the equation. All right, that's what you're looking for. But along the way, we've got these ridiculous numbers that we need to get rid of. And if you look at the numbers, you've got 27, you've got 3, and you've got 9. Now this is where your kind of like, your head should start ticking and go, hang on, they're all linked. Those numbers are linked. All right. So, but remember, we are doing an exponent like algebra paper, and you are dealing with numbers with powers in it. So whenever you see these types of numbers, almost get into the idea and look at the lowest number. That's the clue. The lowest number of that base is, you've got 27, you've got 3, and you've got 9. You're going to go with 3. What you're going to do is on the side, I want you to put down 3 to the power of 1 is 3. 3 squared is 9, because 3 times 3 is 9. 3 to the power of 3 is 27. Now once you do that, then what you can do is you can replace 27 as 3 cubed. You can replace 9 as 3 squared. So essentially what we're doing is, instead of 27, we're writing this as 3 cubed multiplied by 3 to the power of P plus 2Q equals, instead of 9, we actually write down 3 squared. And now that's raised to the power of 3Q. So I hope you guys can see what I've done here. 3 squared is 9. That's why I've highlighted it in blue. 27 is 3 to the power of 3, which I've highlighted in green. Now, the next step is this. When you multiply two bases that are the same, you add the powers. Because think about it. When you have a to the power of m times a to the power of n, this one is a to the power of m plus n. And that's what I'm going to do in this case. So in this case, I'm going to get 3 to the power of 3 plus P plus 2Q equals. Now what we've got is, we've actually got a situation where it's powers of powers. So if you remember powers of powers, you would have a to the power of m to the power of n equals a to the power of m times n. And that's what I'm going to do on this side, which means I'm going to get 3 to the power of 2 times 3Q. So with that in mind, here comes the easy part. All right, the easy part is this. You've got on both sides, you've actually got base 3. Because if you think about it, here's a base 3, here's a base 3. That means you could actually say that the two powers must equal each other. All right, because we've got nothing else at the base there. We've got a 3 as a base, 3 as a base. Now think about it like this. If I have something like 3 to the power of something equals 3 to the power of 5, then you would actually say that that something is equal to 5, because the two powers have to match up. And that's what's happening in this situation as well. The two red parts that I've highlighted should equal to each other. That means we can completely ignore the 3. Just forget about the 3, the base I'm talking about. So I write down the power, which is 3 plus P plus 2Q equals 2 times 3Q. So with that in mind, I am going to do 3 plus P plus 2Q equals 2 times 3Q is 6Q. And now I just need to rearrange so P is by itself. So I've got P equals to 6Q minus 2Q minus 3. And when I do this, I am going to end up with P is equal to 4Q minus 3. Now that's pretty much it for this question, right? Like there's nothing else that you need to do for this question. I think the hardest part, well, it's not really the hardest part. I think the easiest part of this question is that all the clues are given to you, because you're given those numbers 27, 3, and 9, and you're straight away you should go, oh, 27, 3, and 9. That's like, I have to rewrite everything as powers of 3. So with the grades, you're looking at that first line as achieved. Simplification of powers of 3 on both sides. Forming a linear equation gets you a merit. So I would say linear equation, that means you're up to here to get a merit. And finally, your final answer that you give will actually be an excellence question. Now, this is actually one of my favorite excellence questions to do, because it just works out real nicely, and you just need to know how to work those powers, and then you're pretty much good to go. So with question C, what we've got here is a company makes calculators, blah blah blah. Look, and I'm going to be honest, anytime people look at these questions, they start to go, oh my god, it's a simultaneous equations, I don't want to deal with this. Right, if that's the case, what you need to do is come up with a table. A table will always help you guys kind of see things in a different way than words. All right, so what I'm going to do is, I mean, we've got this P, right? This P is the cost. So let's kind of put that together. So the cost is P. So I'm going to create a little table here. I'm going to put cost, which is actually P dollars, right? That's what cost is. Now it also says that P is equal to 2A plus BN. Now if you look at N is the number of calculators. So that's what that N is, and the yellow is the P. So the next part I'm going to look at is the part where it says the cost of making 60 calculators is $740. Now if I was to go back and highlight this whole thing, right? N is the number of calculators, which means 60 calculators cost $740. Now on my little table, I'm going to put number of calculators. So which means 60 calculators cost $740. And if you look at my second equation, I've got 160 calculators that cost $840. So I've got 160 calculators that costs $840. So I've got all of this, but I need to figure out what's the cost of making 300 calculators. So this is the question. So for 300 calculators, what is my cost going to be? So let's look at how do we find the cost of something. And to do that, we go back to the original formula. So we've got P equals to 2A plus BN. Now this is the equation that is going to give me the cost of the calculators given a number. And the question that's asking me is, when n equals to 300, what is P going to be? All right, this is what the question's asking. But the problem is I don't know what A is and I don't know what B is. And it also tells you that in this question, where A and B are some fixed numbers. All right, so with that in mind, now we're ready to actually write a couple of equations, because we've been given these two equations, right? So we can actually say the first one, it costs $740, 2A plus B, and we know that this is going to be 60 because 60 calculators cost $740. We also have a second equation, which is 840 equals 2A plus B times 160. And lo and behold, we actually have a set of simultaneous equations. Now, one of the things I like to do with simultaneous equations is, I mean, I'm going to be honest with you, I hate dealing with negatives because it's so easy to make mistakes, right? So what I generally do is I look at these numbers and go, what if this bottom equation is on the top? So that's what I'm going to do here. I'm going to actually write this as 840 completely separate equals 2A plus 160B, because I know that B times 160 is 160. Then I've got 740 equals 2A plus 60b. Now that I've actually got all of this, what I could do is, I'm just going to kind of section this off there. What I could do is I could actually take the top equation and subtract the bottom equation. So the way I do this is pretty much I go 840 minus 740, 2a minus 2a, 160b minus 60b. Now you might be wondering, why are you subtracting? Because I've got 2a and 2a. If I subtract it, it becomes 0. So in other words, I've got 840 take away 740, which equals 100. Then I've got 2a to take away 2a, which equals to 0. And then I've got 160 take away 60, which gives me 100b. And because of this, I could actually say that 100b is equal to 100. So b is equal to just 1. I figured out what b is. Now I got to go back and figure out what a is. And to do that, I could use any one of those two equations. I'm going to use the 840 equation. So I've got 840 equals 2 times a plus 160 times b. But we know what b is because we've just figured out that b is equal to 1. And we're going to substitute that in. So we've got 840 equals 2 times a plus 160 times 1. So we got 840 equals 2 times a plus 160. Rearrange this. I've got 840 take away 160 equals 2a. 840 take away 160 is that what? 6, 14. What is it? I can't even do my head right now. 84 take away 16. Come on, man. You can do this. 78 is it? No. 78. What am I doing? 78, 68. 680 equals 2a, which means a is equal to 680 divided by 2, which is going to give me a is equal to 340. I guess what, folks, we've got a and b. Now we could actually go find out how much is the cost for 300 calculators, because for 300 calculators, so if n is equal to 300, we know that p is equal to 2 times a plus b times n, right? That's the original equation. So p is equal to 2 times a, which happens to be 340, plus b, which happens to be 1, and then n, which happens to be 300. So I've got p is equal to 680 plus 300, and therefore I can say that p is equal to 980. Now I know this seems like a lot of work, but and you're thinking, oh, surely this must be an excellence question. It's not, because the thing is, like, the equations are actually set up quite nicely. You know, there's no kind of like manipulation that you're doing with your simultaneous equation, and so you end up with a merit for this 980. As for achieves, there's like, if you just get that first equation, which is right here, you actually get an achieve just for writing those simultaneous equations. But of course, like, unfortunately for merit, you've got to get that 980. So really, you can't really make any kind of silly errors along the way, because if you do make silly errors, then the maximum grade you get is actually achieved. With this question, all right, this is something that's actually extremely useful to remember. When you think about odd numbers and when you think about even numbers, right, what you kind of think about it is like, odd numbers generally are written in the format of 2n plus 1. All right. It's just the way it is, because if you put like n equals to 0, then you're going to get like 1 as your number 1. And then if you put n equals to 1, you're going to get 3, and then 5, and then 7, and so on. And if you have, like, say, even numbers, you kind of write it as 2n. So that way you get like, if n equals to 0, you get 0. If n equals to 2, you get, 1, then you get 2, 4, 6, and so on. So this is really important. Now, the next thing is this. When you think about consecutive numbers, if I write down consecutive even numbers, Like, let me just write down consecutive even numbers. I got 4, I've got 6, I've got 8. These are even numbers and they are 3 consecutive numbers. What you'll notice is that the difference between each of these numbers is it's plus 2 and plus 2 of the other one, or we could actually say it's actually going up by 2. But if we compare it to the 4, we're going plus 2, and then so from here to here is plus 2, but from here to here is plus 4. All right, now let me put another number up. Like, let's say I have like 20, 22, and 24. So 20 to 22 is plus 2. 20 to 24 is plus 4. Okay, this is like the first part that's actually that you need to kind of remember or understand or know. Now, if we look at it as 3 consecutive even numbers, now we don't know what these numbers are. So what you don't want to do is don't want to put it as x. You don't want to put even number as an x, because x could be an odd number. Like, you know, if I say x would be 3, but then that's not really an even number. So you don't want to use x, but you can use 2x or 2n. So if I use 2n, my first number is 2n, then my second number is going to be 2n plus 2. And then my third consecutive number will be 2n plus 4. So just to kind of reiterate, all we've done so far is we've just done those 3 consecutive even numbers. Now, the question is actually saying, show that if you add the squares. So I've actually got to square each of these consecutive numbers and then add 4 to it. So if I look at it, I've got 2n squared plus 2n plus 2 squared plus 2n plus 4 squared, and then I need to add 4 to it. The result is a multiple of 3. Now, I'm not going to worry about the multiple of 3 yet, but what I am going to do is I've got this big quadratic equation and I need to expand everything and I need to simplify it all together. All right, so that's what I'm going to do here. 2n squared is 4n squared plus I've got 2n plus 2 times 2n plus 2 plus 2n plus 4 times 2n plus 4, and that plus 4 is right at the end. So I got a whole bunch of quadratic equations that I need to expand, which I'm going to kind of do it slowly here. I've got 4n squared plus 4n squared plus 4n plus 4n plus 4 plus I've got 4n squared plus 8n plus 8n plus 16 plus 4. So at this point, all I've got to do is I've got to collect all the like terms. So what I'm going to do is 4, 8, 12. So I've got 12n squared. Then I've got 4, 8, 16, 24 plus 24n. And then finally the numbers, which is 4 plus 16, 20, 20 plus 4 is 24. So this is my equation all simplified together, right? But if you look at the question is actually saying, show that the result is a multiple of 3. Now, for something to be a multiple of 3, it has to be divisible, like it has to have a common factor of 3. So think about it like this, right? If I have 12, I know 12 is a multiple of 3 because I could actually write this as 3 times 4. If you think about number like 24, I know that this is 3 times 8 because 24 has like a multiple of 3. So when I look at this algebraic equation, can I take a 3 out? I know I can take a 12 out, but I just want to take a 3 out. So I'm going to take a 3 out, which means this is going to become 4n squared plus 8n plus 8. And pretty much that's it, because I've actually just shown that this has a factor of 3, and I'm going to write that as a statement. So something along the line of 3 is a factor, therefore the expression is a multiple of 3. Now I know when this question came last year, people were like, oh, this is such a stupid question, it's just like it's crazy, I can't believe they asked this question. But the reality is there's only a couple of things that you need to know. If you know what an odd, how to write an odd and how to write an even, that's your starting point. Your second point is that the consecutive numbers, so you always got to especially if you're doing like consecutive odd numbers or even numbers, you're adding 2. But if it's just consecutive numbers, you're just adding 1 all the way through 1 and 2 and 3 and so on. And the last bit is like, how do you make something into like a multiple of 3? So that is when you take like 3 out of the brackets, you're actually showing that it's a factor, therefore it's got a multiple of 3. So grades wise, that's a really good thing, I keep forgetting. Grades wise, final answer with an explanation is actually going to get you an excellence. Getting up to this stage gets you a merit, which is, I'm just trying to have a look on the equivalent to stage 1. Oh wow, okay. Just to be on the safe side, I would actually say get to here for a merit. Achieved correct expression for 3 consecutive numbers, so that's those 3 things there, like the 2n plus 2 and 2n plus 4. Or you could actually get achieved from here where you actually expand the quadratic equation as well. Cool guys, that is basically it for question 2D, and then we'll kind of move on to question 3 next. Okay, so with question 3A, it's a nice little achieved question, I think it is. All you're doing really is substituting the values. So you've got 5 plus 2, 4 times x, which happens to be 2, times y, which is negative 2 squared, minus z, which happens to be 12. So the first thing we want to do is we want to do that minus 2 squared. So we've got 5 plus 2, 4 times 2 times minus 2 squared is 4, and minus 12. And kind of working through BEDMAS here. So we've got 4 times 2 times 4, that's 32. Take away 12. 32 take away 12 is 20. 20 times 2 is 40. And what you should get is 45 as your answer. Now you've got to have a correct solution for this question, folks, otherwise you are not getting an achieved for this. So make sure that you know, sometimes it's good to just double check the answer again, just to see that you haven't actually made a mistake, but don't do it straight away. At the end of the exam, maybe go back and have a double check of your answer just to check that you've actually done everything right. Alright guys, so with this question, so I know that when we did this question earlier on, I told you guys that when you have a base of 2, you try and look for other numbers. Now unfortunately in this case, we don't see a 4, we don't see a 8, we don't see a 16. Alright, and don't and I know sometimes people do this when they see 5. I don't know why they automatically write this as 2 to the power of 2.5. Now this is not correct. Okay, 2 to the power of 2.25 is completely something different. It's definitely not 5. And remember that you don't have a calculator. Because you don't have a calculator, you straight away should know, okay, now that's not actually possible, because the only things you know are, you know 2 to the power of 1 is 2, 2 squared is 4, 2 to the power of 3 is 8. Alright, so with that in mind, we've got to figure out a way to get rid of that 5 and 40. Now in your head, you got to kind of go, actually 5 and 40, that's like 5 times 8 is 40, right? So what we're going to do is we're going to rearrange this to 2 to the power of 5x minus 12 is equal to 40 divided by 5. When we do that, we're going to get 2 to the power of 5x minus 12 equals 8, because 40 divided by 5 is 8. Now we've got that 8, we can actually write that 8 as 2 to the power of 3. Hey Talia, welcome. So 2 to the power of 5x minus 12 equals 2 to the power of 3. And because we've because we've actually got the two bases that are the same, we can actually say the two powers must equal to each other. And because of that, we can say 5x minus 12 is equal to 3, and then 5x is equal to 3 plus 12, 5x is equal to 15, and then x is equal to 15 divided by 5, which actually gives you x equals to 3. Now, grades wise, this particular question, if I checked it correctly before, forming a linear equation and solving for x is going to give you a merit. So that means you can't just put the answer, you've also got to have a linear equation, which means you've got to do that 5x minus 12. So you've got to show that working. For achieved, you could actually get achieved when you get to this line here. You're actually looking at an achieved, or if you like make a mistake around somewhere below that, after that third line, you're also looking at achieved for this question. Alright, so question 2, what we've got here is using two squares, calculate how much bigger area the square A is bigger than square B. So all we're doing is just area of square A minus area of square B. So if we do area of a square, that's just base times height. So area of square A is going to be 2x plus 4y times 2x plus 4y minus area of square B, which is 2x minus 4y times 2x minus 4y. Alright, so if that's the case, all you got to do is you've got to expand the brackets and then simplify. So we're going to expand this quadratic here first, and when we do that, we get 4x squared plus 8xy plus 8xy plus 16y squared minus. Now here is where you need to be careful. Alright, when you're actually subtracting a quadratic, it's always a good idea to put an extra bracket here like this, because that minus sign is going to have an impact on the rest of the signs for that whole quadratic. Similar to the one of the questions that we did earlier, it's always a good idea to just put that bracket there. So once again, I'm going to expand the brackets here, but remember I've got this little bracket, this bigger bracket inside of it there. So 2x and 2x is 4x squared minus 8xy minus 8xy plus 16y squared. Red bracket, there we go. Okay, next part I'm going to do is I'm going to simplify this, both of these quadratics. So I've got 4x squared plus 16xy plus 16y squared minus, I'm going to have my little red bracket out there, and inside this red bracket I've got 4x squared plus 16xy plus, no, not plus, minus, sorry, minus 16xy plus 16y squared. Okay, now because of that negative sign in front of that red bracket, I've got to multiply that negative with all of these three terms. So I'm going to end up with 4x squared plus 16xy plus 16y squared minus 4x squared plus 16xy and minus 16y squared. So when I do this, let's see, 4x squared disappears, 16y squared, that disappears, and I'm left with just 32xy. So grades wise for this question, 32xy is going to get you a merit. For achieved, correct expansion, blah blah blah, correct, forms correct expression for the required value of the area of difference. Wow, really? Okay, so you get an achieved just for that line. Forms correct expression for the, yeah, that's it. That's pretty much an achieved there for just writing that first line. Not bad actually, this question. Okay, so with question D, what we've got here is we've got to first I mean, we know this. We know this question is going to be a quadratic equation. It's going to be a quadratic equation equal to 0 at some point, and we got to factorize, all right? We know that's what we're doing. So, but what we do need to do, though, is we need to come up with the equation. Now, if you look at this question, the question says path around the veggie patch. Don't really care about the veggie patch here. It says the path has 3 rectangular sections. All measurements are in meters, blah, blah, blah. She's got concrete enough to make a path with a total of area of 9 meters squared. So, basically, this 9 meters squared that she has is the gray area. And we are supposed to figure out what x is, all right, which happens to be the width of the path. So what we're going to do is we're going to split this up into 3 rectangles. All right, now the first rectangle is quite easy because you could just put that second rectangle at the bottom here, because when we split this up, we've actually got 3 rectangles that we're looking at. We've got rectangle 1, rectangle 2, and rectangle 3, and so we're going to draw them out. So I've got rectangle 1 that looks like this, rectangle 2 that looks like this, rectangle 3 that looks like this, and when we add up these 3 rectangles, we are going to get 9 meters squared. So let me just show you 1, 2, and 3. The next step is we need to actually get the dimensions for those rectangles. Now if we look at rectangle number 1, rectangle 1 has a base of 2 and a height of x, because there's rectangle 1, that's 2 and x there. I'm going to do rectangle 3 next. Rectangle 3 has a base of 4x and a height of x. So I'm going to write that down. So that's going to be 4x and x. Finally, I've got rectangle 2. Rectangle 2's base is actually x. However, this is the only part that you need to kind of understand. Now, rectangle 2's height is not 15. All right? Because if you think about it, we've actually got an x from here to here, and we've also got the measurement of x from there to there. So what we have to do is rectangle 2's height is actually from here, which is 15, but we actually have to take away 2 x's. I hope that makes sense. But basically rectangle 2's height is 15, take away 2x. All right, so what would have happened here is, now that we've got these rectangles, we just go base times height. So we've got 2 times x, which is 2x, plus 15 minus 2x multiplied by x, plus 4x multiplied by x, and this is equal to 9. So at this point, folks, all you have to do is you have to expand all the terms, simplify it to a quadratic, put it equal to 0, and solve, and you're pretty much good to go. That last question as well. Okay, so we are going to actually work on this quadratic. So we've got 2x, we're going to leave it as it is. Then we've got 15 times x, which happens to be 15x, minus 2x times x, which is negative 2x squared, plus 4x times x is 4x squared equals to 9. So simplifying this, we've got 2x squared plus 17x is equal to 9. And getting rid of that 9, we're going to get 2x squared plus 17x minus 9 is equal to 0. And once again, guys, as I've always said with this quadratic equation, if you are comfortable finding it your own way, whichever way it is that you're doing, go for it. As long as you get those 2 solutions, that's all that matters. So what I'm going to do here is I'm going to go 2 times negative 9, which is negative 18. And I'm looking for 2 numbers that multiply to negative 18. and add up to positive 17. So 18 and negative 1, 18 and negative 1 looks good. So then I'm going to get 2x squared plus 18x minus 1x minus 9 is equal to 0. Then I'm going to factorize by two of them by separating them, and I've got 2x x plus 9, and on this side I've got negative 1 as a common factor. X plus 9 equals to 0. Then x plus 9 is a common factor, and I've got 2x minus 1 equals to 0. Now of course the 2x is from there, the negative 1 is from there, and we're nearly there because we've got x plus 9 equals to 0, or 2x minus 1 equals to 0. So x equals minus 9 in this case. And in the other case, we've got 2x is equal to positive 1, and then x is equal to 1 over 2. So the final part is super important. We have to say x is equal to half, as x can't be negative. Because remember, you can't have a negative 9 as a width. And this is really important because when it comes to the grades, for the grade of excellence, you have to actually say correct positive solution with evidence of negative value disregarded. So you kind of have to say that x can't be negative. You can actually say width can't be negative. As for merit, simplifying to a quadratic equation equal to 0. So getting up to this line here is worth a merit. For achieved, like I told you guys, for achieved, forming correct expression for the total area, which is right there, you could easily get an achieved for that. Alright, now let's say you make a mistake in that line and you kind of carry all the way to a quadratic. You know, let's say you got a quadratic equation that's wrong because one of your starting, you know, that second line you made a mistake, but you get a quadratic equation equal to 0, you could also get an achieved for that. So yeah, I mean the main important thing is like split your these types of questions into like little diagrams, work out the height and the base and height, and then kind of work through it, and eventually it should end up as a quadratic. I'm fairly certain that most of the time it's always been a quadratic, and it's always a quadratic where the x squared value is greater than 1. So you're going to have to do this kind of equation, and it's going to be an excellence question, right? So keep that in mind, right? So remember guys, any kind of odd number could be written as something like 2k plus 1. It can be written as odd number, and then 2k can be said as even number. I'm actually going to record this part. So let's say I'm going to go with like the 5th pattern and the 7th, because if I choose the 5th shape, then the next consecutive odd number would be the 7th shape. Alright, now if I was to subtract this, I would actually go 7 squared minus 3. That's going to give me the number of small squared in that 7th pattern, minus 5 squared minus 3. And then I'm trying to figure out whether that answer is equal to 2. But I've got to prove it though. Because I've got to prove it, I've got to actually use algebra on it. Now, I don't actually know what which odd number it is. They're trying to say that for any one of them, which means if my first odd number is 2k plus 1, then my next odd number after that will have 2 added to it. So I hope that that kind of makes sense. So my second odd number would be 2k plus 1, which is that first odd number, plus 2. And if you look at this side example that I've done, because if my first odd number is 5, then my consecutive odd number would be 2 plus 5, which is how I get that 7. and that's exactly what I've done here. So I'm going to simplify this to be 2k plus 3 instead of 2k plus 1 plus 2. All right. Now it says show that the difference in the number of squares between two consecutive numbers. So I've got to take the second odd number minus the first odd number. Then that should actually kind of help me out here. So I'm going to go, what is it? Just like how I did that 7 squared minus 3, because it's kind of like this. Think about it like this. If the 2k plus 3 is like 7, then I've got to replace the 7 with 2k plus 3. And if the 2k plus 1 is like the 5, I've got to replace the 5 with 2k plus 1. So that's what I'm going to do here. I'm going to go 2k plus 3 squared minus 3 subtracted by 2k plus 1 squared minus 3. Alright guys, so just with that previous question that we did in question 2, we're going to do something similar here. We're going to expand it and then get a common factor of 2 out, and if we do that, then this whole thing is divisible by 2. So expanding the brackets, I've got 2k plus 3 times 2k plus 3 minus 3 minus, and remember that big red bracket that we talked about? We're actually going to put that big red bracket this time. Alright, we have to put that big bracket. So we've got 2k plus 1, 2k plus 1, minus 3. Because if we don't put that big red bracket, we forget that negative 1 in front, and then that just stuffs up the rest of the equation. So expanding this quadratic, we've got 4k squared plus 6k plus 6k plus 9 minus 3 minus, inside the red bracket, we've got 4k squared plus 2k plus 2k plus 1 minus 3, and we've got that all in that red bracket there. Simplifying on this side of it, we're going to get 4k squared plus 12k plus 6 minus, and inside the red bracket we've got 4k squared plus 4k minus 2. Now because we've got it all under that big red bracket, we've got to multiply by negative 1. So 4k squared plus 12k plus 6. Have I messed up somewhere here? I'm just wondering if I messed it up somewhere. Plus 6. No, it's all looking good. So negative 1 times 4k squared. So remember this negative 1 times that, negative 1 times that, and negative 1 times that. So we're going to end up with minus 4k squared minus 4k plus 2. 4k squared disappears. 12k minus 4k is 8k. 6 plus 2 is 8. Now at this point I want to actually see that it's divisible by 2. So I'm going to take 2 out as a common factor, which means I'm going to get 2 times 4k plus 4. And basically that is pretty much it. Because at this point I can say that as this expression has a factor of 2, it is divisible by 2. Very similar to what we did in question 2E, or yesterday we were working on that question. So grades wise, folks, getting that final part and explaining with that reasoning is going to get you an excellence grade. Correct simplifies to an expression without any brackets gets you a merit. So this part right here gets you a merit. For achieved, correct expression for the difference between two successive odd number shapes. So achieved is the first line by the looks of it. So yeah, that's pretty much it for this paper, for this question anyway, and I think that's all the questions for this paper. Yeah, it is. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.